Hi, grade 12s. Okay, so we're going to quickly chat about determining the equation of the tangent to the curve. Very similarly to how we were doing it in analytical geometry, where you had to first work out the gradient of that tangent. Then you had to use that coordinate point where the tangent meets the circle, and you substituted it into this equation y equals mx plus c. All right, so we're doing something very similar in terms of the y equals mx plus c. The only thing that's different now is we have a curve, so we have the equation of the curve, and we need to figure out that gradient, right? So visually, this is what we're looking at. We have our curve, we give you a particular point, and we want to work out that equation of that tangent. Now, you'd agree with me that if I had to draw tangents around this curve, there'd be like a million of them, okay? These ones over here would be increasing, these here would be decreasing, these here would be increasing. Now, when we're finding the equation of the tangent to the curve, we want the tangent at a very specific point, okay? That's very important to note. So what we're going to do is we're going to sub this particular point that's given to us into the derivative. If you remember in the beginning, I told you that very loosely, if you want to understand what we're doing in calculus, and this is a very loose explanation of it, is we basically working out the gradient of curves, okay? So when we substitute this point into that derivative, okay, it's going to give us the gradient at that point. Okay, so I wrote down for you, where is it? Oh yeah, I wrote down for you the things. I'm gonna scan this and put it as a PDF document on the group so that you can read this as well. But basically, we need the gradient and we need a coordinate P. Okay, what are we given? We generally given the equation of the cubic graph and the point where it meets, or they can give it to you as an equation of the parabola and the point where it meets the graph. Okay. So here's the steps that we need to follow. Again, I'm going to scan this and put it on the group. You need to find the derivative. You're going to sub, I just said this, you're going to sub that x value into the derivative, and it's going to give you the m value, or the gradient at that particular point. Then you're going to also sub that x value into the normal equation that was given to you. That's going to give you the y value where that x value is. So it's going to give you a coordinate pair. You then sub in this m value and this x and y coordinate pair into y equals to mx plus c. So here's an example for us to try. So I wrote here, find the equation of the tangent to the curve. I've given you the curve. Here's it. Negative 3x squared plus 2x plus 1, where x is equal to 1. You don't have to draw anything, okay? You're just following the steps that I put up there for you. So I determined the derivative. How do we get the derivative? You multiply this by this negative 3, giving me the negative 6, and then you reduce this by 1. Derivative of this would be 2. Now see, this point was given at 1, so I'm going to sub this 1 into the place of x, and you can show the substitution and then work it out on your calculator or mentally, and we get m is equal to negative 4. So this is the gradient of my tangent. Okay, now I need to find that x and y point. Okay, so you subbing in basically this value over here into this equation over here. Okay, and that's exactly what I did over here. Calculated it, I get that it's 0. So here's my coordinate pair. Sub in my coordinate pair into the equation y equals to mx plus c. Okay, so this negative 4 goes there. There's our 1 and 0, 1 and the 0. Solve for c and then rewrite your equation. And that's it. We found the equation of the tangent. Okay. I have another one. Okay, so find the equation of the tangent to this curve. Okay, this time here I gave you a hyperbola, so it isn't only a parabola and a cubic. And I want it where x is equal to negative 2. So I just rewrote my equation like this. Okay, why did I do this? So that it's easier for me to find the derivative. Take this, multiply by the negative 6, giving me positive 6. Reduce this one by 1. I then take my point given to me, sub it into the place of x, giving me my m value. Now I need to figure out my y coordinate. So I substituted that x value of negative 2 given into this equation over here, and I get my value 3. And you can do this all onto the calculator, okay? I then sub it into the equation y equals mx plus c. I told you guys I like to write through whichever point I'm working with. I said that this is, you don't know who's marking your paper at the end of the year, so try and make your paper as easy to mark as possible. I solved for c and then rewrote my equation. And that's how we find the equation of the tangent. We can ask it to you like this, basic, simple, or we can do something a little more complex where we say find the equation of the tangent, okay, to this particular curve, right? And not at a specific point, but we tell you that the tangent is actually parallel to this line over here. Now, in order to answer something like this, you need to remember that if two straight lines are parallel to each other, their gradients are exactly equal. And if two lines are perpendicular to each other, then the gradients multiplied by each other give us -1. Don't forget that theory, okay? So I took this one here and I rewrote it, giving me my 3 as my gradient. I underlined it there for you. Okay, I found the derivative of this here. Okay, there it is. Okay, now this time we're not subbing in any point. Instead, we know what the gradient is, so I equated it to 3. Okay, remember in the previous one, I'm going to shift up there, we were given a point and we had to solve for the gradient. This time we are given the gradient, we need to solve for the particular point. So this is now a quadratic equation. Took all the like terms to one side, simplified, so this -9 goes over there, gives me 12, worked it out, and then I got 4 equals x squared. Please don't forget, anytime you have x squared or y squared or whatever it is squared, when you are square rooting, there are two solutions, both the positive one and the negative one. Please be mindful of that, okay? On your calculator, it only gives you the positive one. Please don't forget that there's a negative one as well. So I found both of them, and then I substituted this value into the original equation, okay, to find my corresponding y value. I did the same thing with that one. Now there's two tangents because there's two coordinate points, and then to find the tangent is quite simple. Y equals mx plus c through this point, y equals mx plus c through this point. We know that for both of them the gradient is 3, and then calculated for c and rewrote the equation. This side here, subbed in this point, calculated for c, and subbed it into the equation, rewrote it out. Okay, and that's finding the equation of the tangent. Okay, based on that information, we can ask you other types of questions. Okay, and this is another type. So I have here, show that this particular point lies on the curve, and then find the equation of the tangent to the curve at this particular point. So whenever we ask to show something like this, what you would do is left hand side equals right hand side. It's the easiest way to prove something. So I took this equation over here, split it up. There's my left hand side and right hand side. I then took the x and y and I subbed it into its relevant places, and you see how my left hand side is equal to my right hand side. Therefore, the point 2 and 8 actually lies on this curve y equals 2 x to the power of 3. Now we need to find the equation of the tangent at 2 and 8. So we're going to find the derivative of this. Okay, there it is. And I'm going to sub in this x coordinate over here to find the m value. Okay, did that. We already have the coordinate points. I don't have to substitute this 2 into the equation to find the 8. It's given to us already. We've got it. So I can just take my y equals mx plus c. M is 12 through the point 2 and 8 and find my equation. Okay. Follow-up question. Find another point on the curve at which the tangent to the curve would be parallel to the tangent in A. So we find in the equation of another tangent, that happens to be parallel to this one here. So if it's parallel to this one here, it shares the exact same gradient. So what I did was I took the derivative, there it is, and I equated it this time to what this gradient was, 12, solved for x, and I get that my answer is x equals 2 and x equals -2. Now this one over here was actually our answer that we just calculated here in A with 2 and 8. So I don't need to do this one again. I'm doing the other one. I subbed in this -2 into the equation y equals x to the power of 3, and I get that y is equal to -8. So this is my coordinate pair. We got that the gradient is 12, and then I subbed it into y equals mx plus c, and there we go. That's our equation.